Revis here will watch me work it. How to find charges for compounds with polyatomic ions. Let's start with some that aren't polyatomic so we can get the process down. When we look at a compound that's already made, we recognize that you always have electropositive side, electronegative. That's how compounds form. And so we split them down the middle. So here's the process. First, assign the negative side. The negative side in this case is -2. We either memorize it or we know how to find it on the periodic table. So the right side is by assignment. And so we have 1 sulfur times -2 gives us -2 side. And we want this to equal 0. So this must be a +2 side. And so 2 times what makes a +2? That's a +1. Therefore, we have K with a +1 and S with a -2 charge. The bottom is math. The top charges. That's the method we're using. Let's do it again here. We positive side. We know that because the first element is always positive. So this is sulfur. It's in group 16. So in group 16, we know that's going to be a sign of -2. That's by assignment. And so we do the math. 2 times -2 is -4. We want it to be 0, so it can be electronically neutral. That's -4. So this must be +4. Therefore, carbon is a +4. Remember, on this side, this is assigned. We assign this based upon what we know or its position on the periodic table. And this side, we must calculate by using simple math. Let's do another one here. In this case, sodium's plus and hydrogen must be minus, and this shocks people because you always want to assign hydrogen a +1. That is not always the case. This is an example. So in this case, hydrogen is standard at -1. So the negative side is -1. We want this to be 0. So we +1. Therefore, sodium is +1. So this is sodium +1 and hydrogen -1. So now let's take a look at doing the same process when we have polyatomics. In this case, we have to decide where we draw the line for plus and minus. There are 2 approaches, and we'll show you one at a time. First, let's do it without separating the polyatomics. To make the assignment, you'll want to draw your positive line and negative line just to the left of the last element. That means this is negative, this is positive. That's because the polyatomic is divided into a minus and a plus side as well. So this entire side on the left will be positive, this will be negative. So we go through the process now of doing simple math. We know we have oxygen is assigned. This is assigned, memorized, a -2. So 4 times -2 gives us -8. So we want this to be 0, so it could be neutral. So this must be a +8. And here's where you have to look at the other assignments. Hydrogen's assigned a +1 by default, and because potassium is in group 1, it's assigned a +1. So right away, we have +2 charges already from these. Therefore, in order for this to equal 8, sulfur must be +6. So that's our assignments of sulfur in here based upon simple math. Let's do the same thing for this polyatomic. I locate the polyatomic and I draw my division line for plus and minus. I start my standard oxygen -2. And so what I notice is that I have 2 times 4 here, just math, times 2. It's going to give me a -16 on this side. So I need the left side to be a +16. So to do that, I know that barium is my standard because it's in group 2. So I'm going to assign that to a +2. And I notice right away I have 2 times 3 gives me 6. So I have 6. So I need 10 because it's 16 minus 6. I need 10. And so what I observe is I have 2 times of phosphorus. In order to get 10, this must be a +5. Therefore, my charges are barium with a +2, phosphorus with a +5, and oxygen with a -2. These are my charges. Let's do the next one here. I know that oxygen is -2. I drew the line here because that's where we draw it. This is the negative side, and this is the positive side. This is -2. So 3 times -2 gives me -6. I need this to be neutral, so that's 0. So this side must be +6. So to do this next, I take a look at these, and what I discover is that copper should be a +1, and therefore 2 times 1 gives me a charge of 2. And now I'm short by 4. So in this case, sulfur is a plus 4. As an alternative, we can do it another way. We can take the polyatomic out. So what we can do to find the charge on sulfur, if that's the only thing we want, is we can take SO3, and we know by memorization that this entire polyatomic has a -2. And so we know the oxygen -2 as a standard. So this is -6 equals 0, same process, plus 6 over here. But we don't want neutrality. Therefore, we don't say 6, we say 4. Get it? We don't want neutrality. We want -2. So in order for that to be -2, sulfur must be a +4. We do the same thing with phosphate. If we happen to know the charge on phosphate, which is -3, and we just want to know what's on phosphorus, we would take oxygen with a -2, and this would be -8. And we don't want neutrality again. Let me cross that out. We want -2 here. We don't want neutrality. We want -3. So we put 8. No, we put what? 5. So that means phosphorus is a +5. And so that's another way to do this. So let's just do sulfate also. So SO4, we know the charge on SO4 is -2 overall. And this time I won't play any games. We'll just go right to work. 4 times that will be -8. And we need -2. So this is +6. Therefore, this is +6. Sulfur here's +6. Over here it's +4. So there you have it. That's how we find the charges of polyatomic ions.